Hi all, today we're gonna talk about gas laws and we use to relate between the gas properties using gas laws. So for the gases, we use specific equations uh, to be able to find specific properties for gases. Okay, here are the gas laws, and uh, if you see inside, so we have Boyle's law, Charles' law, Lussac's law, Avogadro's law, combined law, Dalton's law, and ideal gas law. If you pay attention, you see that in them we have P, we have V, we have a T, and we have N. What are those stand for? These are we use four symbols for the gas laws: pressure or P, volume or V, temperature, which is always should be Kelvin, and number of moles, which is N small n. Let's start with the Boyle's law. Boyle's law basically assumes constant temperature and constant number of moles of gas, and here is the equation for it. P1 V1 equals to P2 V2. What does it mean? We assume two stages of a container that has a gas. First stage, we have a gas with a specific pressure and volume for here for sure, and we try to change the volume and pressure, and in the stage 2 we're gonna find out what change is gonna happen if we have the change in basically in the pressure or the volume. And whenever we have only the pressure and volume involved, we call it Boyle's law. Take this comment, guys. Whenever you see the symbols in the equation, here we see pressure and volume. These are the ones that are changing. Okay, but if you don't see the other two, which is, if you remember in the previous slide, I talked about four symbols that are used in the gas laws. The other two that are not in the equation are always constant. So always pay attention. In the gas laws, the ones that are written are the ones that are changing, and the other ones that are not written are constant. Okay. Here, so in the P1 V1, we have a stage 1 of the gas, and P2 V2, it will be the stage 2 of the same container of the gas. So let me give you an example. So here we have a cylinder equipped with a movable piston, and it has a pressure of 4 atmosphere and a volume of 60 milliliter. So we have here basically the given numbers. We have a P1 and we have a V1. Then it's asking for what is the volume in liter if the pressure is decreased to 1. So now, so it gave us the one side already about the pressure and volume. So we're gonna write it in the one side of it. And then the other one, it says decreased 2. So it talks about the stage 2. What happens if I decrease the pressure from 4 atmosphere to 1 atmosphere? So we're gonna write it down using this equation. So it gave us the P2 1 atmosphere, and is asking for the V2 here. So we're gonna use P1 V1 equals to P2 V2, and we're gonna put the P1 4 atmosphere, V1, we're gonna convert our V1 to the liter. I will tell you why. And then I have 1 atmosphere, and basically we get the volume in liter. I recommend you always divide the side that has a known number by the one that has an unknown number. So I'm going to divide 4 times 0.006. I mean 4.0 times 0.0060, and I divide it by 1.0. It's going to be 24 liter. So make sure you have 2 sig fig and you get the 2 sig fig in the answer. Let's go to the Charles law. What is a Charles law? In the Charles law, basically we are dealing with volume and temperature. Again, we are dealing with the volume and temperature in the 2 stages. When the initial temperature is like it's already there, like we have a specific volume and a specific temperature, and we are basically looking for the volume or temperature based on what is given, what is asking for. Okay, so do you think what is constant here? So we know that when we have volume and temperature in this equation, these are the ones that are changing. So when we have volume and temperature are changing, so the ones that are not changing are going to be pressure and number of moles, basically, that are constant here. The one thing that I want to notice is that the relationship between volume and temperature is always a straight relationship. It means that when the volume increasing, the temperature is also increasing. Okay, so always there is a kind of direct relationship between them. But if I go back to the Boyle's law, there is a reverse relationship between pressure and volume. When the pressure increases, volume is decreases. Okay, so let's go back to the Charles law. So let's answer the question. A sample of gas has a volume of this and the unknown temperature, and when the sample is submerged in ice water at 0, its volume decreases to 2.57. What is its initial temperature? The very important thing to do is always make sure you abbreviate your given numbers. So basically, we have a V1 here, which is 2.80, and it already says decreases 2. So as I said, when you see 2, they usually talk about the second stage, basically. So it's going to be here V2. So the V2 will be 2.57. And then this would be the T2 here, because it says when it's submerged in ice water at this, we have this volume for it. So this is also the T2 here. Just pay attention, guys. Make sure whenever they give you a Celsius or centigrade, always convert to Kelvin. So when you write it down, the Celsius, when they give you Celsius, when you write it down, write in the small letter T. But when you convert it to Kelvin, always in capital, is in capital T. Okay, so pay attention about it. So in the question, they ask for the both of them. Okay, how I know I should use the Boyle's law or how I should use the Charles law? That's a good question. Look what is given in the question. Here, if you look at the given number, they just give us V and T, right? It's volume and temperature, right? Volume and temperature. Basically, they gave us 2 volume and they gave us one temperature. So the only gas law that suits for this one is Charles' law. So I recommend you put the gas law table that I have this in this slide in this basically video. Take a screenshot and put in front of you and see which one is basically has all of the symbol which the question has. When I want to put the temperature inside the this equation, it should be converted to Kelvin. So I will convert my T2 to Kelvin, and I put it in the capital format. The T2 in capital means that I converted to Kelvin. So then I will have 297 Kelvin. Then if I want to find the Celsius, I should subtract minus 273, and this would be basically in centigrade or Celsius. Always, guys, I kind of double say here, make sure the two sides of your equation should have the same unit. Let's go to the combined gas law. This is the combined gas law, guys. Basically, it's the combination of the Boyle's law and the Charles law. P1 V1 divided by T1 equals to P2 V2 divided by T2. Which one is constant here, guys, based on the four symbols we talked about? Number of moles is constant here. So here, basically, in the question, they give us the usual question that they always give 5 known numbers and 1 unknown, right? Because it's 6, 5, they are giving 6 symbols here, basically 1, 2, 3, 4, 5, 6. So always in the question, you should look for 5 known numbers, actual numbers, and 1 unknown. The unknown can be, for example, T2. So in case the T2 is unknown, they should give you P1, they should give you V1, they should give you T1, they should give you P2, they should give you V2, and they ask for T2. So let's do the question here. A sample of gas has an initial volume of 158. So sometimes in the questions, they actually tell you the initial volume. So when they give you that, you know, it's really easy. You just, okay, I know they gave me P1 or V1 here or T1 here. So we already have P1, V1, and T1 here basically, because it says initial volume of this at this pressure and at this temperature. If the gas is compressed 2, so what does it mean when it says 2? It says that it gives you to the guide that I'm now giving you to take you to the stage 2, which is the P2, V2, and T2 here. Okay, so whenever you see 2 in the question, it means they kind of take you to the second stage, okay, to a volume of 108 milliliter, and the temperature in the T2 will be this, and they ask for the P2 here. So that's my given numbers. Always make sure abbreviated, and then whenever I have a Celsius, I put 2 in the small t. And then the first thing we're gonna do, we make sure that we convert our T's to the Kelvin. T1 V1 times T2 divided by T1 V2 here. It needs practice, guys. I recommend you do enough practice to be able to do it smoothly, okay? And get the answer fast, basically, or faster than before. So this is basically 3 sig fig. Make sure the answer should be in 3 sig fig. And one more thing, guys, Do I need to convert my pressure to atmosphere, guys, here? It depends on the question, guys. Okay, so look, it's asking for the final pressure in atmosphere, right? Read the question, is atmosphere. You can do it two ways. You do in the first step, you do not need to convert to atmosphere. So as I did here, right? I did not convert to atmosphere. I just put the millimeter mercury here, and then I just put it here. So what the pressure I get is in what unit, guys? Is in the same unit that is given, right? Millimeter. So my final is the same unit, because we said that the two sides should have the same unit. Because here I input millimeter mercury, so my output also is in the same unit, which is millimeter mercury. So, but it's asking for atmosphere. So at the end, I can convert using the unit conversion for it. Here is, guys, the unit conversion factor for different units of pressure. In the exam, I provide these unit conversions. Basically, so here you can see that 1 atmosphere equals to 1 atmosphere equals to 760 millimeter mercury. So I'm gonna put it here, and this is gonna be my 1.64 is my atmosphere. So you can see that my P1 was 735 millimeter mercury, but my P2 is basically here is 1.25 times 10 to the power of 3 millimeter mercury, and is the P2 in atmosphere is 1.64. The other way to do that is first convert to the atmosphere using this conversion factor, the first. So 735 divide by 760, okay, to get the in atmosphere. Then you put this atmosphere that you get in the equation, and what you get at the end will be in atmosphere. So the both ways are correct. Okay, so let's go to another law, Avogadro's law. So I talked about the Charles law, Boyle's law, and combined gas law. Let's talk about Avogadro's law. Avogadro's law is basically, again, we have volume and number of moles here are changing in this. And what is constant here, guys? What is not showing in the equation? The two other factors that are not showing here are constant. So the pressure and temperature here are constant here. So let's do a question here. The Avogadro's law is V1 over N1 equals to V2 N2. Again, you should see in the question what is given in the question. Then you know what gas law you should use, because there are, if you pay attention, until now we have several gas laws. So it might be difficult at the beginning for you, like confusing which one I should use. So please read the question at the beginning several times and put the gas laws table that I have in this video in front of you. It covers all of the gas laws that you should basically memorize them. So make sure you should memorize those gas laws. But at the beginning, you can put them in front of you to be able to get familiar. The more practice you do, it will be more familiar, and by time it basically goes to your mind. You can also, as I always said, use flashcard to memorize them. So let's do a question. A 4.8 liter sample of helium gas contains 0.22 mole of helium. How many moles of helium gas must be in the sample to obtain a volume of 64 milliliter? So let's do a basically abbreviation. So we have V1 N1 and it says 2 right here. So after this, whatever we have will be V2 here, 64 milliliter. Okay, so which one I should use, guys? I should use the Avogadro's because it has that's the mole here given and the 2 volume. So the only one that I can use is Avogadro's law. So I'm gonna basically use V1 V1 divided by N1 equals to V2 divided by N2. And again, if you remember, I said that known side cross with a cross, use a cross basically rule. I mean, in this kind of equation. So known numbers, which are in this arrow that I show, divide by unknown side number. The 4.8 is the basically multiplied by N2. So I will divide, I will multiply 0.064 by 0.22 and then divide by 4.8. This is gonna be 2 sig fig. So pay attention, guys. What I did here, because my given number was in the liter, I decided to do the other one because it was in milliliter. I converted it to liter. So I put here 0.064 liter, guys. So pay attention. Make sure the two sides have the same unit again. If your V1 is in liter, make sure your V2 should be in liter. Okay, in the Gay-Lussac's law, we have this equation. As you see here, P and T are changing, and which ones is not changing? Are not changing? Temperature and pressure. So, and let's do a question for it. So it says we have a pressure of 2.80 in this temperature, and it says what temperature I have if I have to obtain a pressure of this. So I'm gonna do that, and the answer will be 736 Kelvin. So, and make sure, guys, again, the two sides should be the same unit. So because my two sides are the same unit in atmosphere and also Kelvin, basically I have a Kelvin at the end also is asking for Kelvin. I don't need to do any conversion here. So some questions are easier, basically, you know. Hopefully you are enough lucky, you know, to get this in the exam. Okay, so but pay attention, guys, that always look at your two sides of equation. They should have the same unit, and always the temperature should be in Kelvin. Okay, the other gas law is the ideal gas law. This is, guys, to be honest, is 50% of your questions in the exam. So it's really important law, ideal gas law. It has, if you see, it's PV equals to nRT, and we already know that P is the pressure, V is volume, N is number of moles, T is temperature. What is R? R is a new one that I'm gonna talk about. R is the gas constant. R is gas constant. It means that there is a specific number that is never changes. Okay, let's do a question. Calculate the volume of the compound which has of nitrogen, which has this mole, and the pressure of this and temperature of this. So you might ask how I know that this is the ideal gas law. First, they make it easy for you. They give you that, okay, an ideal gas law has a mole of this and pressure of this. So they tell you in the question that this is ideal gas law. If they do not give you in the question, you can find out how. You see that, guys, we have only one pressure here in the question. We have only one temperature here. We have only one mole here. So the only equation that has only one of each of them in the gas laws, look at that, look at the table now, guys, is the only ideal gas law has this specific property that has only one of each of the pressure, atmosphere, and basically pressure, temperature, and mole, and also volume. It has only one volume. So I recommend you always abbreviate and say, okay, I have only one of each here. So the only equation of gas law that has only one of each is ideal gas law. So I'm gonna use the ideal gas law. I'm gonna substitute the numbers. So P is 1.37, is atmosphere. I don't have a V. Again, N is this one. R is what? Is 0.0821, right? Is the constant. And the T, we should make sure convert it to Kelvin. So R is always this. When you have this unit, okay, then the volume, make sure always known side divide by the unknown side. So I'm gonna divide it by 1.37. Make sure you follow the sig fig rule. I have 3 sig fig in the question. I basically have a 2 sig fig. You are right. So it will be, the final answer should be 2 sig fig at the end. Okay, so let's do another question, which is also ideal gas law. Pay attention, guys. So let's read the question here. So they already make it easy for us. They just tell us that's the ideal gas law. A sample of gas has a mass of this. So they have a gas. They gave us a gas. So I will, okay, the mass is this one. The volume is 0.112 liters. So I'm going to write it down. Temperature is 298. Okay, I'm happy. Is in Kelvin. Okay. And the pressure is also in atmosphere. Okay, that's good. Also, I have atmosphere here. Then is asking for what? Find its molar mass. And it says find the gas from the periodic table. Well, that's okay. The teacher didn't tell me about that. Okay, so there is a trick here, guys. This is the ideal gas law, even if they don't tell you. Why? Again, because they gave us one of each, VT and P, right? The only one that has the equation that has only one volume, temperature, and pressure is PV equals to nRT. So what I'm gonna do, I first find the mole from the ideal gas law. So I'm gonna do it first. I'm gonna use the ideal gas law. And then I find the mole. P, I have the P here. If I have a V, I have R, I have a T. And then I find the N. That's the N, guys. Make sure they follow the sig fig rule. Then the second step is using the regular equation that we were finding the mole before. If you remember, in the empirical formula, we were using this equation to find the mole of the compound. Number of mole equals to mass of the compound, or mass of the basically element divided by the molecular weight. So I have the mole here. I got it from number 1. That's the mole I got from calculations. In this question, I put my gram that is in the question, is given already in the question, and I find the molecular weight. It's 288 grams per mole. You might ask, how you know what gas is that then? Okay, guys, we have some diatomic gases like nitrogen gas, oxygen gas, hydrogen gas. So then also we have all the noble gases. So you make sure, guys, it will be between those. They don't give you more than those. Just look at the gas laws. I mean the noble gases and also the diatomic gases that we have. So here, this is a nitrogen gas. So the only one that matches with 28 gram is nitrogen gas here. Okay, the other one is Dalton's law of partial pressure. So it's really simple, guys. Dalton's law states that if we have for example, air, guys, in this room that we are, look at your room. We have air, right? The air has for sure nitrogen, oxygen, and argon. We just write down some of it. So you will see that if I assume, okay, this is the partial pressure of the basically my N2 here. I just write a fraction of it, in atmosphere is basically at this atmosphere, and they gave me already, that's the partial pressure for oxygen, and also they also gave me in the question this one. I can add them up based on the Dalton's law. I can add up the partial pressure of gases to get the total pressure of the gas. That's it, guys. It's just an addition, basically. So pressure of total equals to addition of the partial gases, okay?